Leaving Cert Higher Level Maths, Exam 2017, Question 1, Section A. Factorise 64x cubed minus 125. So what we have to do here is get the difference of two cubes. So we're going to factorise using the difference of two cubes method. And that's because we have a cube number, a minus, and a cube number. So this is the formula for the difference of two cubes. X cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. So you really just have to learn this off by heart. So we're going to get the cube root of 64, which is 4, the cube root of x cubed, which is x, and the cube root of 125, which is 5. So we can rewrite 64x cubed minus 125 as 4x cubed minus 5 cubed. So the 4x is our x and the 5 is our y. So I've highlighted in yellow all the x values, so we're going to replace all those x values with 4x. And I've highlighted in green all the y values, so we're going to replace all the y's with 5. So we end up getting 4x minus 5 times 4x squared plus 4x times 5 plus 5 squared. 4x minus 5 stays the same. 4x squared becomes 16x squared. 4x times 5 is plus 20x. And 5 squared is 25. So this is our answer. We factorised using the difference of two cubes. So this is a summary of the special factors that we encounter in Leaving Cert Higher Level. So we've got the difference of two squares, we've got the sum of two cubes, and we've got the difference of two cubes. So you need to learn off these formulas by heart. B. Show that for all real numbers, a is greater or equal to 2 root ab minus b. So the key word here is real. So basically what we want to end up showing is that we have something squared greater or equal to 0. So what we want to do is get everything on the left of the inequality sign. But first we have to sort out this root part. So we're going to start by bringing the minus b over to the left hand side. So we get a plus b is greater or equal to 2 root ab. Then to get rid of the root, we're going to square both sides. So we have a plus b squared greater or equal to 2 root ab squared. A plus b squared gives us a squared plus 2ab plus b squared. And that's all greater or equal to 4ab. Because root ab times root ab is ab. And 2 squared is 4, so we get 4ab. Then we're going to bring this over the left hand side. So it becomes minus 4ab. And all of that's greater or equal to 0. Then we simplify. 2ab minus 4ab is minus 2ab. So we've got a squared minus 2ab plus b squared greater or equal to 0. Now we can factorise. We bring down the a squared, we bring down the b squared. And we have to factorise the minus 2ab. So we're going to break that up into minus ab minus ab. So that's technically minus 1ab and minus 1ab. And minus 1 is minus 2. We can factorise the first two terms. So we get a times a minus b. We factorise the second two terms, so we get minus b times a minus b. We notice that we've got a minus b inside both sets of brackets, so that's going to be one of our brackets. We bring down the a, we bring down the minus b, and we also have a minus b in the other set of brackets. A minus b multiplied by a minus b is the same thing as a minus b squared, and all of that is greater or equal to 0. And we know that this statement is true, as all square numbers are positive. So anything squared must be greater or equal to 0. So if this is true, and this is just a rearrangement of this, then this must also be true. Part C, solve the simultaneous equations. X plus 3y is equal to minus 3. X squared plus y squared is equal to 13. Okay, so what we're going to do is take the simpler equation, which is the x plus 3y is equal to minus 3. So this is the linear equation. And this is the circle equation. And we're going to rearrange the simpler equation to get either the x or the y in its own. So I'm going to get x equals minus 3y minus 3. So I've just brought the plus 3y over the equal sign. Next, I'm going to substitute this into the second equation. So I'm going to swap that x squared for minus 3y minus 3 squared. So I've got x squared plus y squared equals 13. The x squared becomes minus 3y minus 3 squared plus y squared equals 13. Minus 3 times minus 3 squared, I'm going to work it out over here. So minus 3y minus 3 multiplied by minus 3y minus 3 ends up giving us 9y squared plus 18y plus 9, which I'll write in here. I bring down the y squared. The 13 comes over the equal sign, becomes minus 13, and that's all equal to 0. I simplify. 9y squared plus 1y squared is 10y squared. Bring down the 18y, and 9 minus 13 is minus 4. Next I'm going to divide across by 2. 10y squared divided by 2 is 5y squared. 18y divided by 2 is 9y. Minus 4y divided by 2 is minus 2. Next I'm going to factorize, and I'm going to solve, or I could have used the minus b formula. Bring down the 5y squared, bring down the minus 2. The factors of 5 times 2 is going to be 10, so the factors of 10 is 1 by 10 and 2 by 5. So I'm going to go with 1 by 10. So I've got a minus here, which tells me these signs are going to be different. And I'm going to go with 10 and minus 1, because 10 minus 1 gives me 9. I factorise the first two terms, 5y times y plus 2. I factorise the right two terms, minus 1 times y plus 2. I've got the same thing in both sets of brackets, so y plus 2 is going to be one of my sets of brackets. Bring down the 5y, bring down the minus 1. So next I'm going to let 5y minus 1 equal to 0, so I get y is equal to a fifth, and I let y plus 2 equal to 0, so y is equal to minus 2. Now I have two y values. I'm going to substitute both of them into the simpler equation to get my x values. So the simpler equation is x equals minus 3y minus 3. So I get x equals minus 3 multiplied by a fifth, minus 3, which is minus 18 over 5. And then x equals minus 3 times minus 2 minus 3, which is 3. So my y values are minus 18 over 5 and 3. I was asked to solve, which means find my x values and find my y values. This is a line and this is a circle. If I was asked to find the points of intersection, which is the same method, I would have one more step at the end where I would put my coordinates together. So I would say the first point of intersection is minus 18 over 5, comma, 1 over 5. And the second point of intersection is 3, comma, minus 2.